Okay, we're looking at the second reason for electrolysis, which is electroplating. So electroplating means using electrolysis to put a layer of metal onto another metal object. So this is coated in gold. It's got a layer of gold on it. This could have a layer of silver or copper or whatever other chemical that you wanted to put, metal you wanted to put on. Chromium on the tap and on the bike and on car wheels, and a silver on spoon. So you're coating a layer, so plating a layer. So the reason that we do electroplating, metals like iron are cheap and plentiful. The world is covered in iron rocks that we can get iron metal from, but silver and chromium and these things are rare. The thing is that silver, chromium and gold are very unreactive. They don't oxidize easily. They don't lose their electrons and become ions. So oxygen can't steal the electrons from them very easily. It will. Silver can oxidize, and they can oxidize, but the oxidation layer that they form stays intact, whereas iron oxide flakes off and keeps corroding. So gold doesn't oxidize. So it's better to have these metals, but they're rare. They also look better, so we might want to electroplate a thin layer of these metals to make it look better. So the process, the electrons have to be removed from the sample of the metal that you want to plate. So if you want to coat your spoon in silver, then you need a big piece of silver metal. So the object that is going to be coated has to be the cathode. The electrons have to be coming from the battery onto here to force the silver ions that are on to turn into silver metal. So you have to attach whatever it is that you're electroplating to the negative end of the power supply. If you attached it the wrong way round, then your spoon would be losing electrons and it would fall apart. So you have to be careful how you attach it. The positive ions, so if you're taking electrons from this silver metal, you're making silver ions, they move across and get the electrons. So they move across to the cathode. This is the anode. So therefore the reaction is with the same metal. You're undergoing a reduction reaction with the silver here and an oxidation reaction with the silver there. So the silver is reacting with the silver. Because you have to, this all has to happen immediately, you have to have a supply of silver ions in the solution, so that obviously you can't remove an electron from here and have that silver ion that's formed move directly across here to accept the electron again to make silver metal. You already have to have some silver ions here ready to immediately accept the electron to complete the circuit. So you have to have some sort of silver salt. So you can see on your electrochemical series that this is not a spontaneous reaction. You don't normally have silver ions reacting with silver metal. If the spoon is made of iron, what would happen to it when it was added to the silver solution? If you put the spoon in the silver solution, if the electricity wasn't turned on to start with. So if we look at the electrochemical series, you can see that this is in the right pattern to undergo a spontaneous reaction. The silver ions are a stronger oxidizing reagent than the silver Fe2+, iron 2+, so it will oxidize the iron, which means that a spontaneous reaction will occur with the spoon if it was made of iron, and it would start to get eaten away and form ions. When the power supply is turned on though, any electrons that would be lost from here spontaneously are being replaced by the power supply, so the iron atoms remain intact. So they're just being used as a means of supplying the electrons as a conduit for the electrons. So that's why we don't need to worry about the cathode, what the cathode is made from. We don't have to worry about it losing its electrons, because the power supply will add them back again, which is why often iron, apart from electroplating, iron is quite often used as a cathode, because it's a cheaper material. If you don't have to worry about what it's made from, you may as well use a cheaper electrode. We don't have to use an inert platinum electrode, because basically iron in this case will be inert. It won't react.